Hello and welcome back to another learning series with Mr. Knight. Today's topic is on the reactions of acids. The types of acid reactions that we are going to look at today include acid reacting with metal, acid reacting with metal oxide, acid reacting with base or alkali, acid reacting with carbonate, acid reacting with hydrogen carbonate, and I'm also going to include the reactivity series of metals. Now let's look at our first reaction. This reaction is acid reacting with metal. When acids react with metal, the reaction produces salt and hydrogen gas. Now let's look at an example. In this example, magnesium reacts with hydrochloric acid, but a point to note, for this reaction to take place, magnesium must be able to replace hydrogen. Now, it therefore means that magnesium is more reactive than hydrogen. And so this reaction will produce magnesium chloride and hydrogen gas. Remember to always balance your chemical equations. And so to balance this chemical equation, it requires a 2 in front of hydrochloric acid, which means 2 molecules of hydrochloric acid. And also you can put your states. Now, based on this example, and as I mentioned before, is that for a metal to replace hydrogen, the metal must be more reactive. So let's sit tight and observe the reactivity series of metals. Now, displaying in this diagram, the metals on the left, they are more reactive than hydrogen, and they are able to replace hydrogen in acid-metal reactions. The metals that are displaying on the right, they are less reactive than hydrogen, and they are not able to replace hydrogen in acid-metal reactions. Now, the problem is always trying to remember the lineup of this reactivity series. And so, a very easy way to remember it is this. So notice this statement. It said, please strew chicken, meat, and zucchini in nicely trimmed lamb. Howard carried sweet garnish pickles. And so, the P represents potassium, the S represents sodium, C for calcium, M for magnesium, A for aluminum, Z for zinc, I for iron, N for nickel, T for tin, L for lead, H for hydrogen, C, which is the other C, it is for copper, S, it is for silver, G for gold, and P for platinum. And so this is a very nice way for you to remember the lineup of the metals in the reactivity series, starting from the most reactive to the least reactive, and we're comparing these with the reaction of hydrogen. So remember, please strew chicken, meat, and zucchini in nicely trimmed lamb. Howard carried sweet garnish pickles. And so, let's look at an application of this reactivity series. Let's say we're going to react gold with hydrochloric acid. Think about the reactivity series. Is gold more reactive than hydrogen? Absolutely not. And so therefore, when gold tried to replace hydrogen, then this will not take place. Hence, there will be no reaction at all. And so for this reason, we can clean our jewelry, if it is pure gold or pure silver, with any acid, in a matter of fact, because the jewelry, if it's gold or pure silver, will not react with the acid. All right, let's jump into our other reaction. And this is acid-base reaction, or reacting acid with alkali. And so acid react with base to produce salt and water. Now let's look at an example. Let's take in, for example, magnesium hydroxide reacting with sulfuric acid. This reaction, as you notice, it is like a double replacement reaction. And so this reaction will produce magnesium sulfate and water. Again, remember to check if your equation is balanced. Remember, some equation will balance automatically and you're good to go. All right. So if you notice this reaction carefully, the magnesium will go with the sulfate, and so it forms magnesium sulfate. The hydrogen will react with the hydroxide, which is OH, and give you HOH, which is water. All right. So beautiful going. All right. So this reaction is now balanced as it is. And so we can now jump into our other example, acid plus metal oxide. And a point to note is that acid reacting with base and also metal oxide, they are a form of neutralization reaction. And so acid reacts with metal oxide to produce salt and water as well. And so let's look at an example. Let's say we react calcium oxide with hydrochloric acid. Again, the calcium replacing the hydrogen. And so what you'll get in this case, you get calcium chloride, that will be the salt. You'll also get water. And again, always check to make sure the equation is balanced. And so now the equation is balanced, and you can observe it carefully. Let's now jump into our other reaction. And this one is acid reacting with carbonate. So acid reacting with carbonate, for example, acid plus carbonate gives you salt, water, and carbon dioxide. Now let's look at an example. So potassium carbonate reacts with sulfuric acid. Again, the potassium will replace the hydrogen. What you get is potassium sulfate, water, and carbon dioxide. Again, always check to make sure the equation is balanced. Some equation balance automatically. All right, and this is one of such example. Now let's look at the other reaction, which is acid plus hydrogen carbonate. And this will be our last reaction for today. And so acid reacts with hydrogen carbonate to produce salt, water, and carbon dioxide, just like acid reacting with carbonate. Now, an example of this is sodium hydrogen carbonate. And sodium hydrogen carbonate is a formula for baking soda, or the scientific name for baking soda. And so NaHCO3, that's a chemical formula, reacting with hydrochloric acid. Again, the sodium will replace the hydrogen within the acid. And so you get as a result sodium chloride, which is stable salt, water, and carbon dioxide. Again, check to make sure the equation is balanced. All right, and now we are at the end of the lesson, and I hope this really helped you. And so I am looking forward to see you in the other lesson. So stay safe.